Okay, so now we're going to move on to first principles. Essentially what first principles is how do we get from the original function of x to then the derivative of x? So we're going to have a look at an example. So okay, so our question is, prove from first principles that the derivative of x cubed is 3x squared. So we're going to try prove that if we can. Well, we can prove that. So we have to define our gradient. So I'll switch to a blue pen. So our gradient is equal to y2 minus y1, you should know this from GCSE, x2, x1, where y2 and x2 are one set of coordinates, x1 and y1 are another set of coordinates. And basically, this is the change of y divided by the change of x. So if I draw a scruffy diagram, so I'll draw it in red pen here. So that's good enough. So this is A, this is B. So A and B. So the change, sorry. So the change in x is going to be x plus h minus x. That's what we're defining as the change in the gradient. X plus h. We're going to call that tiny increment of increase h, because it's easier than putting it as delta x, where delta is not a function, it's only a small increment in change. And then the change in y is going to be defined as the function of x plus h minus f of x. That's what we're defining as. This is the change in y, where h is the small increment. So, okay, that's all simple and fine. Then, how do we get from x cubed to 3x squared? First of all, we have to fully define our y2, y1, x2, and x1. So, our x1 and x2 do not change. They hold true for all derivatives. So, and gradients, sorry. So, x1 is going to be defined as just x, okay? x2 is going to be defined as x plus h, where h is the small increment, small change in increment, I must say. y1 is going to be x cubed. So our first set of coordinates is going to be x and x cubed, okay? And then our y2 is going to be x plus h cubed. And that comes from the function right here. And then the function of x is just x cubed, where cube's on the outside, and x plus h minus x. So x1, they hold true for all. And upside down, capital A is for all. And then depending on what equation you get originally will define what sets, what change in y do you get. Hence y is the derivative of y with respect to x. So, our function of x. So, the derivative of a function of x is equal to the limit, or lim, as h tends to 0, you always put h tends to, limit of h as h tends to 0, our y2 minus y1 and x2 minus x1. So we have x plus h cubed minus x cubed. over x plus h minus x. That is our change in y, as is that, and that is our change in x, as is that. So we're going to keep going. We're going to say the limit as h tends to 0, and we're going to expand the top and simplify the bottom. So we're going to put x cubed plus 3x squared plus, 3x squared h, sorry, plus 3xh squared plus h cubed minus, all minus x cubed. So, and then dividing that all by h. That's it. Okay, so what we're going to do, we're going to cancel those, the two terms on the top. So we're going to say the limit as h tends to 0, 3x squared h plus 3xh squared plus h cubed divided by h. So that makes sense. That's meant to be a h, by the way. Okay, so we're going to keep going. So what we're now going to do, you're probably thinking, okay, I'm kind of seeing the pattern. If you spotted that pattern, then we know where we're going to go from here. So we're going to keep going once more. Okay. So we're going to say the limit as h tends to 0, h 3x squared plus 3x h plus h squared all divided by h. As h tends to 0, all these terms go to 0, except for that one. You're probably seeing the pattern, but let's just keep going for one more. They cancel. Sorry, I forgot to put that. So we're going to say that the limit as h tends to 0, 3x squared plus 3xh plus h squared. And that is our final statement. So we're now going to say, So we're now going to say that as h tends to 0, 3x squared equals 3x squared, 3xh equals 0 if you put in h equals 0, and h squared also converges to 0. Therefore, the derivative of x cubed is 3x squared. It's not bad for all of that. And that is true. And this holds true for all. Literally, I'm not being joking. This is as easy as it gets. You'll have such simple ones. This is worth about, I'd say, 4 marks or roundabout. If you have more, if you have more terms here, then perhaps it'll be like up to 5 marks. But it will always be between 3 and 5 marks. It's not difficult. It's following the same procedure over and over again. So it's literally not a problem, and it's relatively easy to do. Just follow the same steps over and over again. So now, following this, I'm going to give you 2 exercises to do, and then next time we will cover equations of tangents, equations of normals, and stationary points.